Greetings, mathematicians. Today we're looking at example 1 for complex fraction, simplifying a complex fraction by method 1, which is basically a fraction divided by a fraction. Now, in step 1, sometimes you do have to get a single fraction in the numerator and get a single fraction in the denominator, but 1 is already good to go. So we can actually go straight into step 2, which is dividing this fraction. But in mathematics, we don't divide fractions, we multiply by the reciprocal of the second fraction, or the fraction in the denominator, and then we simplify. So let's follow these steps. One of the things I like to do is I actually rewrite this problem, and instead of the big fraction bar, I change that to a divide sign. So that's going to look like 5x squared over y, divide sign, so writing it exactly as it appears, but just instead of a fraction bar, divide sign. So 10x divided by y, and then I change that to 5x squared divided by y times the reciprocal y divided by, well, actually that should be 10x over y squared. So this would be y squared over 10x. And I could go straight from the problem to multiplying by the reciprocal, but I like to show the divide sign and the original fraction to show the equivalency. So now what I have a fraction times a fraction, so numerator times numerator, denominator times denominator. And I am going to show that with prime factorization and expanded form of the exponents. So in other words, 5 times x squared times y squared is the same thing as 5 times x times y times y. There's my 5 times x squared times y squared. And in the denominator, I have y times 10 times x. Well, I'm going to show the prime factorization of 10, so that's 2 times 5. And then I'm going to do times x times y. Since multiplication is commutative, I can rearrange it and still get the same answer. Now I can start simplifying in those terms, because this factor of 5 divided by that factor of 5 simplifies to 1 over 1. Identical factors, x divided by x simplifies to 1 over 1, and y divided by y simplifies to 1 over 1. So now in the numerator, what's left that didn't simplify to 1 is x times y, times 1 times 1 times 1 is x times y. And just going to write x, y. And in the denominator, 2 times 1 times 1 times 1 is just 2. And so that is the final answer, the final simplified answer. And I do like showing the expanded form and prime factorization of numbers, but I could have simplified up here as well. For example, 5 divided by 10 simplifies to 1 divided by 2. X squared divided by x simplifies to x over 1. Y squared divided by y simplifies to y over 1. And I get the same answer. 1 times x times y gives me xy in the numerator, and 1 times 2 times 1 gives me 2 in the denominator. Now, they both work. I do like showing the expanded form and prime factorization because everything is already simplified, or is already factored out and cannot be simplified further. Sometimes here you have to simplify after simplifying, and I'm not a big fan of that. I would rather show the prime factorization in expanded form. All right.